So last time we started mathematical logic. Now we'll start with the truth table, and this is the most important thing in the whole lesson. What we took yesterday was just preparations for today. So we start with truth table. The truth table shows the truth or falsity of a compound statement. We know what is a compound statement. A statement that is made up of two or more simple statements. And we know that the truth value of the statement could be either true or false. That is, a statement could be either true or false. And the truth table or this table will show us whether the statement is true or false. First, we'll start with the truth value for negation. We have statement P, it is raining. So we have statement P is true. True means it is raining. And it can also be false, it is not raining. So the statement P will first write the two possible values. It could be either true, either false. Now, when we take the negation of P, negation P would be the opposite. True, the opposite of true would be false, and the opposite of false would be true. Negation P, it is not raining. When we say P, it's raining, the negation will be the opposite, it's not raining. And when we say P, it is raining, the negation of P would be true. It is, when we say it is not raining, then the negation of P would say it is raining. So this whole is called the truth table. It shows us the statement, whether it is true or false. Here it shows us statement P, whether it's true or false. And it also shows negation P, whether it is false or true. That was a simple statement. Now we will do for another statement for conjunction. Conjunction that is using and. We know this is the simple for conjunction. We have statement 1. We have P as statement 1 and Q statement 2. P and Q. We want to know what is the possible truth values for the statement P and Q. Compound statement P and Q. First, we will start with the statement P itself. We will write all the possible values for P and Q. They could be both true. They could be true.
Husnaya, your voice is again breaking up. I don't think it's internet. I think you should just remove your earphones. Hello.
Can you hear me?
Yeah.
If it breaks, just tell me so I would repeat again. I guess I will need to change the headphone set.
Yeah, I think it's your earphone. You just remove the earphone. I think it will be fine.
Okay.
Yeah. You removed it now, right?
No. If I removed it, I can't speak.
Your laptop does not have mic?
No, it doesn't.
Oh, okay. I understand.
If my voice breaks, just tell me so I would repeat again.
But now it's very clear, I think. If you can just keep your headphone like this, it will be good.
Okay, we'll try. So we start with the truth value for conjunction. That is when we join two compound statements using the connective and. It's called conjunction, compound statement for conjunction. We have first P, the statement 1, and we have Q as a statement 2. We want to know what is the possible truth values for P and Q. When we say P and Q, what are all the possible values? First, we write P and Q, and we'll see what are the possible truth values for P and Q. First, both of them could be true. One could be true, the other false. One could be false, the other true. Or both of them could be false. When we say conjunction and, it means both of them depend on the another. Both of them have to be true, so we have the conjunction true. When we say P,
it's again breaking up. Yeah.
The truth value for conjunction. We have two statements, P statement 1 and Q statement 2. We need to find the possible values for the truth. We need to find the possible truth values for P and Q. We will write all the possible values for P and Q, that is all possible true and false values. Both P and Q could be true. One could be true, the other could be false. One could be false, the other could be true, or both of them could be false. This thing we write it on by ourselves. It doesn't, it's simple, like how we used to do for probability. Next, we will come to P and Q. And here is the important part. When we say and, it means both P and Q should be true so that we can get the P and Q as true. Like here we say P is true and Q is true, so we have P and Q is true. Like for example, if P, roses are red, and Q, the sky is blue, we say roses are red and the sky is blue, which are both true statements. Roses are red and the sky is blue. So P and Q would be true. Next, when we say true and false, it will give us false. Why? Is because we are saying and. When we say true, when we say the first one is true, then the second one also should be true. Otherwise, it will give us a false statement. For example, we have roses are heavy and earth is round. This is a false and true. Roses are heavy, it's false because roses are not heavy, they are light. And we have Q, the earth is round, which is true. So we have false and true is false, opposite true and false is false. Is it clear so far? Why we got false here?
Yes, yes.
Yes, yes.
Okay. Next, when both P and Q are false, when both the statements are false, it will obviously give us a false compound statement. We have P, 2 plus 2 is 9, and Q, 4 plus 5 is 10, which is both false. 2 plus 2 is not equals to 9, and 4 plus 5 is not equals to 10. So this gives us a false statement. That is false, and false give us a false compound statement for and. Is it clear so far?
Yeah.
Yes,
So
yes.
this is the value for conjunction. We need to keep this in our mind. Next, we'll go to disjunction. Truth value for disjunction, that is or. We need to know what are the possible truth values for P or Q. Similarly, we have P statement 1 and Q statement 2. We will write all the possible truth values for P and Q. Both P and Q could be true. One could be true, the other could be false. One could be false, the other could be true, or both of them could be false. So when we say P or Q here, we say or. So when the first one is true or the second one is true, then it gives us a true value. When we say or, then we don't care if both of them are true. We just need one value to be true. Either P is true or Q is true, so it gives us the value true. Like when we say here, P is true and Q is false. Here we say P or Q, that is true or false. Like when I say roses are red or 2 plus 3 is 6. Roses are red is true, but 2 plus 3 equals to 6 is false. But I'm not saying and, I'm saying or. I'm giving you an option. Roses are red or 2 plus 3 is 6. And from here you can see one of them is true. So the compound statement would be true. Similarly for the opposite, false, the P is false and Q is true. So it will give us P or Q is true. When we say or, one of them have to be true. So it would give us the answer or the compound statement true. But when we say P is false and Q is false, then it gives us P or Q as false, since both the statements are false, or I'm lying when I'm saying the statements. 2 plus 3 is 6, or 9 minus 10 is 5, which is not true. 2 plus 3 is not 6, and 9 minus 10 is not 5. So in this case, I'm lying in both the statements. So the compound statement P or Q is false. This is for disjunction, that is the or. This also we need to kind of by heart it or understand it so we can solve the questions. Next, we'll do conditional connectives. Is it clear so far? Conjunction and disjunction?
Yes, yes.
Yeah.
Okay. We said we have 5 connectives. That is or, and, if then. If then is one of the conditional connectives that we'll be using it now. When we connect two connectives or when we connect two simple statements using if then, it gives us a compound statement, and it is denoted by the simple arrow. For example, let P be I was the car. I wash. Sorry, here H.
It's okay. It's okay.
Yeah. Let P be I wash the car, and Q he will give me money. So when we join these two statements using if then, we say if I wash the car, then he will give me money. Now here we are joining it using if then, the connective if then. Now we will do the truth table for the connective if then. Similar to the truth table of conjunction and disjunction, we will write the possible values of P and Q. Here we write the possible values for P and Q. Both P and Q could be true. P could be true and Q could be false. Could be false true, or both of them could be false. Now when we come to if then, we say if P is Q, then true is false. Like we have in the example P, if I wash the car, then he will give me money. In this case, I'm not lying. If I wash the car, if I did my mission, if I did my job, then and then only I will get the money. If I wash the car, then he give me money, so it's true. And next, we have true and false. If I wash the car, he did not give me money. In this case, I'm lying. If I wash the car, if I did my job, I should receive my money. But he didn't give me my money, so here the statement is false. That is, uh, I'm lying here. So we have the compound statement as false. Next, when P is false and Q is true, if I did not wash the car, that is false, then he will give me money. Here I'm saying if I did not wash the car, if I didn't do my mission, then he will give me the money, because here it depends, the truth of the statement depends on Q. It depends on the second statement. The second statement have to be true, so we would get the compound statement as true. Next, when both the statements are false, it will be true, because here, if I did not wash the car, then he will not give me money, which is clear, like which is reasonable. If I did not wash the car, if I did not do my job, then he will not give me the money, which is true. This table could be a little confusing in the beginning, so it would be better if you just kind of try to by heart it. True is true and true false is false. It means it will give us true value for all conditions except when P is true and when Q is false. Is it clear? That is
Okay.
conditional connective if then. Next, we have the biconditional connective using if and only if. Conditional connective if then, but in biconditional connective if and only if, and it is denoted using the symbol here, double-sided arrow. This is the symbol for biconditional connective if and only if. We have an example. Let P be the grass will get wet and Q it rains. P biconditional connective to Q, it will be the grass will get wet if and only if it rains. There is no other reason for the grass to get wet if it does not rain. So if and only if it rains. The truth table, we have we will write the possible values for P and Q, possible truth values. Both could be true. One could be true, the other false. One could be false, the other true, or both could be false. When both the conditions are true, that is, if the grass will get wet if it rains. That is true statement. If the grass will get wet if and only if it rains. There is no other reason for the grass to get wet if it doesn't rain. So the compound statement would be true for biconditional connective. Next, when we have the first statement true and the second statement is false. That is, the grass will get wet if it does not rain. If is false, so here we say if it does not rain, which is false because there is no reason for the grass to get wet if it does not rain. Next, we have false and true. The grass will not get wet if it rains, which is also a false. If it rains, it means there is nothing covering the grass, so of course it is going to be get wet. But when I say it rained, but there was no water on the street, so obviously I'm lying, so it will be false. Next, when we have both the statements are false, the grass did not get wet and it did not rain, it would be true because here I'm not lying and I'm saying something obvious. The grass did not get wet, it did not rain, so of course it's going to be a true value. If and only if, that is biconditional connective. Is it clear so far, the truth value, the truth table?
Yes.
Okay, next. Here we took the truth table. Next, there will be different types of truth tables. All truth tables are not the same. We have three different truth tables: tautologies, contradiction, and contingency. We'll take each one of them. First, when we say tautologies, a statement is said to be a tautology if it is true for all logical possibilities. That is, for the statement P should be true and the statement Q also should be true. Then only we say for that truth table as it is a tautology. To be clear with an example, we have an example P or negation Q. We will call P or negation Q as a tautology if the truth table or the last column of the truth table is true. Where we have P, we will write the possible values for P. It could be either true, it could be either false. We will do negation. Sorry, this should be negation P, not Q.
Can you explain this part, like P, P
Yeah.
and this
Yeah,
is
I'm explaining it.
okay.
We need it to be a tautology, so it means the last column should be all true. Here we're having example. We have P or negation P. This is or P or negation P. First,
Yeah.
we will write P and we will write the possible values for P. P could be either true, could be either false. There are no other possible values. And
Yeah.
then when we say negation of P, it means the opposite of P. When P is true, then the opposite would be false. When P is false, the negation or the opposite would be true. So far, so clear. When we come to or, P or negation P, that is we are saying true or false. I'm giving a statement. It could be true or false. In this case, the compound statement would be true because I'm saying or. So I need at least one truth value, so I could say the whole statement is true. True or false would give us true.
Right. Okay.
False
So it
and
works for or, right? Yeah.
yes, this is for or. If I said and, then in this case, I both would be false because and means both of them should be true.
True.
But
Right.
in or, that is in or, one of them should be true. So it would give me the whole compound statement as true. So here,
Yeah.
true and false would be true. False and true would also be true. So we can say that this statement is a tautology, or this truth table is tautology because the last columns give us all true values. Clear?
Yes.
Here we have another example for tautology. We need to show that P by conditional Q, P conditional Q or Q conditional P is a tautology. When we have such a question, we need to make the truth table for each statement. First, we make truth table for P, a truth table for Q, then truth table for P if Q, if then Q, Q if then P, and for P if Q or Q if then P. First, we'll start with P and Q. We write the possible values. If it is true, P could be true, true, could be true, false, could be false, true, could be false, false. Now we'll start P if then Q. If P is true, then Q is true. It will give us a true statement. If P is true and Q is false, it will give us a false statement. And if P is true, P is false, and Q is true, then it would give us a true statement. And if P is false and Q is false, it would give us a false statement. Sorry, here it should give us a true statement.
So what does
True
this
statement.
means? P arrow Q. What it means exactly?
If then
Okay.
if then the conditional connective arrow is if then. We took the
I was
truth table. If then, if it is true, true, then true. If it is true, false, then it will be false. If false, true, it will be true. And if false, false, it will be true.
one
The
second,
same
please.
table, we're doing it.
If I wash the car, then he will give money. If I wash the car, he did not give money. Okay. If I did not wash the car, then he will give money.
Yeah.
If I did not wash the car, then he will not give me money. Okay. So I think here will be a false, right? In the third line.
Last,
No, third line.
third line.
Yes.
No, it would be true. It would be true because it's depending on Q. Q or the second statement have to be true, then only we'll get it true. Or
No,
both
I
the
mean,
statements
like if the statement is if I did not wash the car, then he will give money. So he will not give money in that case, right?
yeah.
So I think the answer should be false, no?
Yeah, that's also what I thought. The answer should be false, but it's actually true because, and if then it depends on the, it depends on the second statement. It depends on the second statement. If the second statement is true, then it would give us a true value for the whole compound statement.
It's a little confusing in here.
Yeah, I know it's a little confusing. I also thought it was wrong, so I referred other books, other videos, but all of them say
If you
the
just
same
go
thing.
a little bit up, one screen above, we will be able to understand this one. Connecting two connectives using if then to produce a compound statement. It is denoted by the symbol. Let P, I wash the car, he will give me money. Okay, so this is P, this is Q. Okay, by default, P and Q are true statements, right? So
yes.
Okay, if I wash the
That
car,
is for the
then
first
he.
case. That is for
Right.
the first case.
That is
Both
for
the
the first
statements
case.
are true.
Okay.
Yes.
If I
If I
wash the
wash the
car, he
car,
did not give money.
he will give me.
Then he will give. But it is still confusing here for the third line, I'm not able to.
I know why the third line. Yeah, I know the third line have to be false. That's also what I thought, but it's actually true because it's dependent on Q.
Okay.
Bro, note is false. Actually, note is used for false. So in first P for false, not.
I can't hear what you're saying.
बड़ा वाला ले लो ना, चेंज नहीं है मेरे पास. अच्छा ठीक है, बाकी मैं से बाद में लेना, रात को शाम को ले लेना. Hello.
Yes.
Okay, so like what I am not able to understand here is, are we considering the first line to be correct? Like this one, he will give me money.
You're saying the second statement, Q?
Okay, so I understand here. Yeah, the second statement Q, by default it is he will give me money. So
yes, I care about what comes after the word N. I need to know what comes after the word N. Then is true, so then the whole statement would be true.
Okay.
Then is false, then the whole statement would be false, except for the last case. Because in the last case, I'm saying if false, then false, it should be true. Because if I'm saying something false and another false, then it will give me a true statement.
Okay. If I
If
did
I'm
not
saying
wash
I
the
did
car,
not
then
wash
he will
the
not.
car, he did not give me money. In this case, I'm not lying. If I'm coming and saying this to you, in this case,
Mhm.
I'm not lying. So my statement
Yes.
would be true. My compound statement would be true.
Okay. Okay.
If I am correct, note is used for false. Am I right?
Hmm?
Yeah. He's saying not is
Note
used for false.
false.
Yes, not is used for false.
Yeah, yeah. I understand. I understand. Okay, okay.
Okay. We need to like practice doing it, then only we can get. The easiest way is to kind of by heart this table, especially for conditional connective, because here it's confusing when it comes to the third line.
Yeah.
Yeah, then let's get back here. We said if true, then true will give us a true statement. If false, then false will give us a false statement. If false, then true will give us a true statement. And if false, then false will
Okay.
give
So
us
this is
a
a
false
rule.
statement.
Yeah. Now it makes sense. So it is a
Yeah,
rule
it's a rule.
that if then is true, then the whole statement is true, right?
Yes, yes.
Okay. I understand now. So it's a rule they have
Okay.
made that if the then condition is true, if the then
Then the
condition,
whole statement is
then the
true.
whole statement is true. Okay, I understand. Yes.
Yes. Okay. Now we solve the truth for if P then Q. And next we have Q if P. We have first, we will only be seeing Q and then P, okay? We'll say if true, then true will give us a true statement. If false, then true would give us again a true statement. If true, then false would give us a false statement. And if false, then false would give us a false statement. Similar to what we did here, but the opposite. We're starting with Q and then P.
Yes, yes.
Okay, now we will be doing the OR for both of these tables, or value for both these two tables only. True or true would give us true value. False or true would give us a true value, because we said in OR, OR we
Any
need
one of
only
it has to
one
be right.
true. Yeah, any one have to be true, then only it will give us the whole statement as true. If true or false would give us true, or true again would give us a true value. Here we got the last column, all true values, so it's called a talogy. Clear?
Yeah.
Next, we'll do contradiction. Contradiction is the opposite of talogy. In talogy, we said all the last values have to be false, but in contradiction, talogy, all the last column have to be true. In contradiction, the last column have to be false. For every statement, it have to be false. Here we have an example.
Can you slow down here and
P.
please repeat?
Okay, we said contradiction means a statement in which all the possible truth values are false. The last
Okay.
column, all the values need to be false.
Okay.
Okay, we have an example: P and negation P. It's not clear. P and negation P. We have
Right.
first P. We write the possible values for P, which could be either true, either false. Now we will write negation of P. It could be negation of P would be the opposite. True, it will be false, and false, it would be true. Now we will say P and Q. Here P is true and false. It will give us false statement, because we said for and both of them have to be true, then only we'll get true. We can't have one true and one false. Both have to be true. So we will say true and false. It will give us a false statement. Similarly, false and true would give us a false statement. So this is an example for contradiction. We can say this statement is contradiction because the last column for the truth value give us all false statements. Clear?
Yes.
Clear, clear, clear. Okay.
Okay. We need to show that P and negation Q is biconditional P if then Q. We need to show that it is a contradiction, means the last column all should be false. Similarly, we'll do it again. While solving such problems, what we have to do is just the first two columns. The other all columns depend on the question itself. P and Q is the only thing that we write it on ourselves. The other columns depends on the question, whether we need negation P, whether we need negation Q, whether we need and, or, if then. Okay. So we write the possible values for P and Q. It could be both true, could be true false, could be false true, or both could be false. Now we will write negation Q. That is the opposite of Q. We need negation Q. That is the opposite of Q. So it will be true would be false, false would be true, true would be false, and false would be true. That is the negation. Next, we do P and negation Q. We need P and negation Q. So we see these values. So we see true and false would give us a false statement because it's an and. True and false would give us false. True and true would give us true value. False and false would give us again a false value. And false would give us a false value. Because in and, everything is false except for true and true. Clear this part?
In last one, false and true is false.
False and true would be false because it is an and.
Okay.
Okay, yeah.
False and true would be false. And next we have P if Q. This is the similar one which we had
I think
confusion in.
there is one thing I would like to add here, because some
Yes.
people are getting confused, and it's not because of how you're telling everything right. The part where everyone is getting confused is that when you see the question P and negation of Q, and after that we
Yes.
have the double arrow is called what? It is called conditional, or what it is called?
They are biconditional.
Biconditional, yes. And then we have a
Yes.
bracket P, and this one is called
Conditional.
conditional, P conditional Q. So
Yes.
I know where everyone is getting confused. You are, first of all, you see that statement and that seems very confusing because you don't know what it does. Therefore,
Yeah.
the way to solve it is that you have to first divide all of, like what Husnia has done. She made, first of all, you don't need to worry about the entire statement, okay? The entire expression. You just write the most simplest forms. Like first she write P, then she write Q, okay? That is after Q, we need this negation of Q. That is also needed. So after she wrote Q, she made a table for negation of Q. Then comes our first term, that is P and negation of Q. So now once we have the value for P, Q and negation of Q, we can calculate this P and negation of Q. Okay. Afterwards, she made next table. That table has P conditional, right? What it is
Q.
called?
Yes. Yes.
P
B conditional
Q.
Q.
So now we have the values for P and Q. So we calculated P conditional Q. Once we calculated both this table, P and negation of Q, and then P conditional Q. Now we have our this one, that biconditional, if and only if. Okay. So now you know, if and only if, it's only going to be true if both the conditions are true, right? That is what the if and
Yes.
only if condition does. That's why now when we want to check that, none of this table has both the condition true. That's why all of them are false. Therefore, these
Yes.
expressions they can look confusing, but never get confused. And with time, they are going to
Yeah,
be
it's
tricky.
quite simple.
Yeah, it is simple. You just have to break it down into parts, because we will also be reading this in computer. I think in C or fundamentals, in either of them, we will find this truth table and all that. So there is nothing to be confused about. Okay, just break it in small parts.
No any other formula to remember it very fast.
It's not about formula. There is no formula used here. Listen, bro. You just have to remember what the signs mean. For example, this triangle, like this A-like triangle, that is the sign for and. Okay. And you have to remember in and, if both the statements are true, only then the complete statement is true. Okay. That is what you need to remember first.
Okay.
and then next comes the triangle with which is like V. Okay, in that is called OR case. In OR case, let's say I have 100 rupees or I have 1000 rupees. So either of the statements can be true, right? So overall, my complete sentence is not wrong. I can
I am confusing symbols. So just tell me these symbols meaning, then I'll remember it and
listen. You
solve
cannot
it.
remember it like this. I will tell you what. This is to remember this, you have to read the PDFs to 1, 2, 3 times. Only then you will be able to remember it. Because if you just try to remember it now, you will forget in 2 minutes. Okay. So, but still, for once, I will explain this A like symbol. That is the and symbol. Okay. This wave like symbol. It is the negation. Negation means whatever you are saying, the opposite of that. That is what negation is. Okay. Next.
Okay.
Okay, this is the and statement. See, in this PQ.
This is the or.
Okay, sorry, it's or. Okay, in this
This
PQ,
is
both
or.
are true, statement true. One of them is true, statement true. One of them is again true, Q is true, P is false, statement still true. And both of them are false, then it's false. So this is what the result of
Okay.
or. Okay, in or
Okay.
you have most chances of getting your statement correct. If even one statement is correct, your compound statement, complete statement is considered to be correct. Next, we have and statement. Okay, see, now here, because now you are implying in or you are giving options that this can be true or this can also be true. But here you are saying no, this is this and this is this. They are both together. So you are saying roses are red and the sky is blue. Okay. In this case, yes, that is both the statements are true. Roses are red, and with that you added, and yes,
I got
sky is also blue. So both true,
it.
true. But next line is roses are heavy and the earth is round. Now here, now you are confusing the whoever is in front of you, because now you are saying roses are heavy and the earth is round. Now one of your statement is right, one is wrong. You're not giving an option, you are telling them a like an absolute statement. In this case, it's going to be wrong. Similarly, here we have P 2 plus 2 equal to 9 and Q 4 plus 5 equal to 10. Both the statements are wrong. Okay, both the statements, so the entire statement is wrong. So this is what and, this is the case of and statement. Understood? And
Okay.
just
Okay.
like that, if you read the PDFs, you will be able to remember the signs. Okay. For example, the condition, the biconditional, that is if and only if. In that case, only if the entire condition is true, then it's true. Otherwise, it's false. Just like the and one.
What the arrow means P and Q. This arrow only.
Which one? This
Yeah,
arrow.
yeah.
This
This
yeah,
arrow.
this is if and only. If and only if. This arrow means if and only if. If it is double arrow, and if it is single arrow,
This is if then.
if then, yeah. If it is single arrow, like here it's single arrow, so it is if then.
Mhm.
If I do this,
Then.
then this will happen. Okay, and in this, the then one has a rule. If ever then condition is correct, the whole statement is considered to be correct. So these rules you will remember if you read the PDFs a few times. They will be shared after the class in the Telegram group.
Okay. Okay.
Okay,
That's very
Husmaya,
good.
go ahead, please now.
Okay.
Sorry, sometimes I have
So
to
we are
interrupt.
doing this.
Okay.
No, it's fine. So we are doing this table and we found what you said, by looking at the statement at first, it could be very confusing. You wouldn't know where to start with, but you just need to simplify them. First, we have P and Q. So we have P and Q the statements. So we write the statement P and we write the statement Q. Next, we have the negation of one of the statements, negation Q. So we will start with the negation Q. There is a rule, which one we have to follow first. I will explain now. Which one we have to do first, and or, if conditional, negation. I will explain this now. So we'll start now with negation Q. We will write all the possible values for negation Q. Next, we have P and negation Q. So we're going to find the answer for P and negation Q. P and negation Q. We're not using Q while solving. P and negation Q. We'll write all the possible values. Next, we have P conditional Q. We will write the possible values for P conditional Q. Last is we have what to give. What's the statement given in the question? P and negation Q, biconditional P, conditional Q. And here also we'll again solve it, and we found that all the statements are false. So this is called a contradiction. This table or this statement is a contradiction because the last column, in the last column, all the statements are false. Next, we have contingency. For contingency, it will be the statement or the table is neither a tautology nor a contradiction. It means in the last column, we will have mixed true or false values. It won't be everything false like in contradiction. It won't be everything true like in tautology. It will be a mixing between false and true statements. For contradiction, if you search the notes, nothing is written about it. There is no example about it. Even the questions, there is nothing about it. Like there is no question about contingency, but I will still give it to you because it was mentioned in the videos. This question is actually there is a mistake actually in the question that was given by the teacher himself. So that's why I'm skipping this part. But you need to understand that for contingency, it means that in the truth table, the last column would be a mixing between true and false statements. It won't be whole false. It won't be whole true. It will be a mixing between true or false statements. If I got another question tomorrow or day after tomorrow, I will show you. Because if it's possible, we'll conduct another session and I'll be solving with you such questions, such proofs, because then it will be more clear. Okay?
Okay.
Next, we have logical equivalence, or this sign. It's called logical equivalence. But when writing it's not, we don't do complete lines. Let me show you how it looks like. I can't find the sign here. Yes, here. Logically equivalent. This is the sign for logically equivalent, and we discussed this sign yesterday in Demorgan's law. We said the statements we say are logically equivalent using Demorgan's law. When we say logically equivalence, what we mean is that the last column for the first statement and the last column for the second statement should be similar: false, false, true, 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 and then again true and true. Then in this case only we can say the first statement and the second statements are logically equivalent if the last column for each one of them is similar. Here we're going to prove Demorgan's law. We said according to the law, negation of conjunction, negation P and Q is logically equivalent to negation P or negation Q. We need to prove that. So this statement could be a little overwhelming, so we're going to divide it. First, we're going to write P alone and Q, and we'll write the possible values for P and Q. It could be both true. One could be true, the other could be false. One could be false, the other could be true, or both of them could be false. We got P and Q. Next, we need to find P and Q and statements. If true and true, then it will give us a true value. If true and false will give us a false value, because in true, both should be true, then only it will give us a true value. If false and true would give us a false value. If false and false would give us a false value. We finished here. Now we need to find the negation of P and Q. We found P and Q. Now we need to find the negation of P and Q. Negation means simply the opposite. When if it is true, it will be false. When false will be true. When false will be true. And when false will be true. We are done with the first statement. You can either make this as a table by itself, and the another part you can make it another table by itself, or you can join them together. Next, we need to find negation of P. We have P, we need to find negation of P. We have P is true, the negation would be false. True, negation would be false. False, negation would be true. And false, negation again would be true. We found negation P. Next, we'll find here the negation sign is strong. Negation P. Next, we need to find negation Q. That is the opposite of Q. We have Q true, it will be false. False would be true. True would be false. And false would be true. Now we need to find negation P or negation Q. If we said false or false, will give us a false statement. We said false or true, will give us a true statement because we need at least one true value or one true statement, so we could say the whole statement is true. True and false would give us true, true and true would give us again a true value. Now, can we say that this statement and this statement are logically equivalent? For that, we need to see the table. We need to see the table for this statement. That is this table. We have false, true, true, true. And now we need to find the values in this table. That is here, false, true, true, true. They are similarly false, false, true, 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 and then again true, true. So we can say these two statements are logically equivalent. Clear?
Yes, crystal clear.
Now we'll go to negation of disjunction. This is also Demorgan's law, and we see the negation of disjunction. We have negation of P or Q is logically equivalent to negation P and negation Q. To find or to know if they're logically equivalent, the table for this and the table for this should be same. So first we'll start by writing P and Q alone. P is true, Q is true. It could be true, false, false, true, false, false. Now we need to find P and Q. Can we find the negation before finding P and Q? No, it would be hard. So first we'll find P and Q. We have P and Q. True and true would be true. Sorry, this is OR. P or Q. True or true would be true. True or false would be false, because in OR we need at least one true statement. So the whole compound statement could be true. False or true would be true. False or false would be false. Now we'll find the negation of this statement. Negation of P or Q. And negation is the easiest. It's just the opposite. If it's true, true would be false. True would be false. True would be false. And false would be true. We completed this part. We found the truth table for this statement. Next, we'll find the truth table for this statement. We can't find it at once. We'll separate each one alone. First, we'll start with negation P. We have P. We can find P. True would be false. True would be false. False would be true. And false would be true. We found negation P. Now, similarly, we'll find negation Q. True would be false. False would be true. True would be false. And false would be true. We found negation Q. Now we need to find and negation P and negation Q. False and false would give us a false statement. False and true would give us again a false statement. Similarly, true and false would give us a false statement. True and true would give us a true statement. Here we found the table, the truth table for this statement, and we find the truth table for this statement. Now we need to see, are they similar? We have F false here, false here, false here and false here, false here and false here, true here and true here. So are they both logically equivalent? Yes, the two statements are logically equivalent. But in case we have here, let's say true. In this case, can I say this statement and this statement are logically equivalent?
No.
Yeah, we can't say because they are not similar. Here we have 3 false and 1 true. Here we have 2 false and 2 true. So in this case, it's wrong. They are not logically equivalent. Now when we say the rules we need to follow while solving them, what should I start first? Should I start first with the bracket? Should I first start with or and negation? Now we'll be discussing the rules. Rules to follow while solving the truth table for a compound statement. We need to look for the connectives with higher priorities. There are some connectives that is the conjunction or and some of them are higher priorities. Some need to be solved before the another. First, the number bracket. When we have a bracket, we need to solve the bracket fast. That's why here we first solved P or Q, then only we did the conjunction because the bracket have the higher priority. Next, we need to do the negation. When we have a negation, then it has to be solved fast. Like in here, we have negation P and negation Q. We didn't do P and Q. First, we did the negation P, negation Q, and then only we solved and. Next, we have the conjunction. First, we need to solve the conjunction. And and then only we'll solve or. Here, each one of them is different. This is a statement and this is another statement. So that's why we solved first or and then Q. But if this was another conjunction or and, then we have to solve conjunction first and then we'll solve the or. Last, we have the disjunction, that is the or. Or would be solved after we solve and. The last is conditional and biconditional. Like in this case, here we have another question, another example. Yes, here, like in this example, we have conditional and we have biconditional and we have brackets. So which one would we solve fast? According to the rule, first we solve the bracket and then both of them have the same priorities. So we're going to solve them by starting from left to right. From starting left, we have first the conditional, so we'll do it first, and then we will do the biconditional. Now here we have negation P and Q according to the rules we followed. So which one are we going to solve first? The bracket, negation, or the and statement?
Bracket.
Bracket.
First, the bracket. First, we'll solve the bracket. That is, and then next we're going to find solve the negation P. After solving negation P, then only we can do the and. Then only we can do negation P and Q. Here we have P and Q or R. We have and we have or. We have conjunction and disjunction. So which one are we going to solve first according to the rule?
Conjunction.
First conjunction, we're going to first solve the and then we're going to solve the or. That we're going to first find P and Q, and then only we'll solve or Q or R. And the last condition, biconditional, we said both of them have the same priorities. So we're going to solve them by starting from left. Whoever comes to the left, we're going to start solving from there. Clear?
Yes.
Any
Clear.
doubts so far?
No.
Okay. Last, we'll be discussing about the applications. What are we using all these things for? Conditional, biconditional, truth table. What do we use them for? We said in the beginning we use them in circuits. So now we're going to see how we use them in circuits. So in 1930s, Claude Shannon observed the relation between operations of switching devices and operation of logical connectives. He found that the logical connectives and or are similar to the switching devices that are used. This is the diagram for the current flow. We have when this is a switch. When it is closed, then we say the current flows. When the switch is closed, obviously, then current will flow. And when the switch is open, current does not flow. This is a circuit diagram. Here we have the switch, we have the lamp, and we have the battery. In this case here, the switch is open. So will current flow or no?
Will not flow.
It will not flow since it's open. We need to close it, then only the current will flow. This, we can express it in a statement. So let's say S1 is the switch and L is the lamp. We said let P be the statement where S1 is closed. P would be the statement where S1 is closed, and L be the statement where L is on, or where the lamp is on. Lamp is on if and only if the switch is closed. So in this case, we can say P is logically equivalent to L, because if P closed, then only lamp will be on. Clear?
Yes.
So we can say P and L are logically equivalent. That is, if a switch is closed, the lamp is on, or if the lamp is on, then it means the switch is closed. Because if we enter a room and we see the lights are on, then it's obvious that someone switched on the lamps. Here another circuit, but it have parallel switches. We took in physics, when we have parallel switches, if both of them have to be closed, then only current will flow. One of them have to be closed, then only current will flow, isn't it? Let's say if S1 is closed and S2 is open, will current flow?
Yes.
Yes, it will flow, because it will flow from here to here. There is nothing that stops it from flowing. Similarly, if S2 is only closed, then again current will flow through it. So we need to show this in a statement form. So we'll say let PBS1 is closed, or the first switch is closed, QBS2 is closed, and LB lamp is on. We said S1 or S2 should be closed. One of them should be closed. That is or. That's why we said P or Q will be logically equivalent to L. P or Q is closed, then only lamp would be on. Clear?
Yes, got it.
Yeah, so that's why we said both are logically equivalent. This is for parallel circuits. Here, we have parallel circuits S1, S2, and S3, but these two are not parallel. These two follows one and another. So can I say I can only close S2 and the current will flow?
No.
No, because here it's open. It needs to be closed, then only current will flow. So now we're going to make a statement for this. We'll say S1 let P be S1 is closed, and Q be S2 is closed, and R be S3 is closed. We have P S1 closed, Q S2 closed, and R S3 is closed, and L would be lamp is on. Now we need to show the statement where current will be flowing through them. For current will be flowing, we need this closed, and we need this and this closed. We need both of them closed. It's not or like the first time. It's not or one of them. It should be and. Both of them should be closed. So we would say Q and R. That is S2 and S3. Both of them have to be closed. When both S2 and S3 are closed, S1 could be or could not be closed, because since they are parallel, then one of them have to be closed. That's why we are using or. P or Q and R. That would be logically equivalent to L. Is it clear?
Yes, got it.
Okay. So that much we have for today. If it is possible, we can conduct another session the coming days, and I'll be solving the examples and the questions that are present. It will be more easier to understand the circuit and the truth tables.
Yes, Husnia, you will complete the chapter.
Okay.
Yeah.
So if there is any doubt before we end the session?
Yes. Anyone has any questions? If yes, you can unmute your mic and ask.
No question. No.
Okay.
No question.
And today's session was very good because her voice was totally clear now, and she has explained everything very nicely. And I am actually surprised how like we are all students, but it's going very well. You know, the people who come to teach us, They are amazing, seriously.
Thanks.
Okay, so I will just end the session. Okay, and the recorded sessions will be available on YouTube in case you want to revisit, or also the PDFs for today's session and this video will be available on our Telegram channel, so that if you want to go through, you can go through there also.
The YouTube channel
the link is also in the Telegram channel. If you have the link for Telegram, you don't have the Telegram channel?
Yeah, I have Telegram channel.
In the description of the Telegram channel, the YouTube is there. Although I will still share it in our WhatsApp. Okay.
Okay. All these recorded class are there.
Yes. Until yesterday, whatever class has been taken place, it's there.
Nice. Okay.
This will also be updated by today.